So today we're going to look at one example of a series, and then we're going to use one of the many methods to check whether it converges or diverges. So here is one trigonometric series, cosine n pi, n goes from 1 to infinity. Now if we make an expansion, it's going to be interesting, right? So just to show you, so it should look like this. So cosine pi plus cosine 2 pi plus cosine 3 pi, right? And then so on and so forth, right? All the way to infinity. So if we work these out, right? So what's cosine pi? Well, here's a graph of cosine, right? So cosine, one period of cosine makes 2 pi, right? Here's pi, 0. So cosine pi is -1, right? And then cosine 2 pi is 1. And then you see how it's going to keep repeating, right? And oscillating. So we're not expecting it to be converging. Now, however, we can confirm by using the integral test, because this is a continuous function, right? So let's rewrite it. We'll write it as an integral. So we're going to go from 1 to infinity, and then I'm going to just change the variable to x. Okay, so cosine pi x. How's that? Okay, so cosine pi x and then dx, and then see what the integral is. So if we take the integral of cosine, it's going to be sine, right? So sine pi x, and then by the chain, remember to keep in mind chain rule, and we have to reverse it. So on the outside, you're going to have 1 over pi, right? So and we can write 1 to infinity, and then we know this is an improper integral. So I can rewrite it as, okay, so I have 1 over pi, and then this is going to be limit, right? Okay, so we're going to have sine pi x, okay, and then minus the lower bound is going to be 1, right? So sine pi. Now we know when sine goes to infinity, this is not going to converge to any value. So you know this is already not working, right? So this is or it actually doesn't exist. So that's why we can tell also by integral test that this is going to be divergent.